Welcome to video 5.4 in our first Principles of Astrophotography series. In this video, we discuss light pollution filters.
Yeehaw. These filters attempt to find a balance between passing nebula emission lines and excluding light pollution.
This video is based on section 5.4 of our first Principles of Astrophotography book, which is linked in the description below.
I'm Ren Edwards.
And I'm Boyd Edwards.
Let's talk sensor sensibility. Principle 90, light pollution filters. Light pollution filters broaden the pass bands of dual narrowband filters to include more nebula emission lines while excluding sources of light pollution.
This is the transmittance spectrum of the Optolong UHC filter, and it's quite popular. Here's the 500 nanometer oxygen line, and I think this is its brother, the little bit lower wavelength oxygen lines. So this filter passes those oxygen lines. This might be the hydrogen beta line, but it can't be called a dual narrowband filter because it's this bandwidth is around 50 nanometers or so. Then the hydrogen portion of it is wide also. It looks like it's even more than 50 nanometers. It might be 70 or so. But it passes the hydrogen, the nitrogen, the sulfur. So that's what they do. They broaden the dual narrowband spectrum to include more emission lines while avoiding the light pollution lines. So these orange lines are all man-made emission lines. I'm not sure which is which, I can't remember. But mercury vapor lighting in your street, sodium lighting, there's high pressure and low pressure. We're trying to avoid these sources of man-made light pollution and keeping as much as we can of the light that we really want.
The problem is us ding-dong people, we put this light right in the middle of our visible spectrum.
That's kind of the point,
yeah,
because you want to see,
yeah,
right? Yeah.
It's the worst for astrophotography, but it's great for seeing.
Yeah, it's great for seeing the road, yeah.
And just as an aside, with the last video we talked about the C-star, and the C-star is somewhere between
Didn't we say 30 nanometers for
30
this?
nanometers on the oxygen, yeah.
So it might look something like
So it's a little wider than a narrow band, but it's a little narrower than a light pollution filter. So it's somewhere in between the two.
Yeah, it's a hybrid.
Yeah.
And then didn't you say that the hydrogen was 20?
Yeah.
So
it's pretty narrow on the hydrogen.
So it's going to be something like that.
Yeah. Mm-hmm. But it's still not like a narrow band.
The line between a dual narrowband filter and a light pollution filter gets kind of blurry.
Oh, yeah.
There, right?
Yeah.
Ultimately, a light pollution filter, ultimately any narrowband filter could be thought of as a light pollution filter because we're trying to get rid of the light pollution and keep the emissions that we are interested in.
Yeah.
But that's just how the field has evolved. So Optolong also makes something called the L Pro filter, and notice how these differ. It differs from the UHC.
This is some black magic here, what they did.
Yeah. So they're trying to straddle these sources of light pollution, these orange lines, and capture some of the light in between those sources of light pollution. So the idea here is that you could use one of these filters to shoot, for example, a galaxy and capture some of the light. Not all of the light of the galaxy, but trying to improve the whole idea of a filter is to try and improve the contrast of your image. And especially those that live in light polluted areas, these might be a really nice option for you. We're lucky enough to live in Bortle 4, and we have a Bortle 2 site that's within a 45-minute drive, so we do most of our imaging at night. Isn't it interesting?
Weird, huh?
Imaging at night, yeah. at our Bortle 2. And so yeah, we're blessed that way, and we know it.
Yeah.
We understand that. Thanks so much for watching.
And we'll see you next time.